Okay, so we are going to go over how to find the domain when there is a sum or a difference operation occurring to two functions. In this case, this is a difference operation. And how do we find the domain of this thing? Okay, well, when you have to find the domain of a difference or function operation occurring, you must uh, find, find the common domains of original functions. Okay, so oftentimes it's easiest to represent this on a number line. So the first thing we need to do is find the domain of f of x. So if I want to find the domain of f of x, I'm going to notice that this is a radical function because there's a square root symbol. And remember, you can't square root a negative value. So that means x minus 4 must be greater than or equal to 0. So I'm going to solve for x in here. I'm going to add 4 to both sides. And I will get x is greater than or equal to positive 4. So if I start my number line here, I have 4, and this includes it, right? We have that equal sign. So I'm going to do a closed circle, and it has to be greater than positive 4. So this is f of x's domain. Now I'm going to find g of x's domain with the red pen. So g of x domain. And I'm going to notice that this is a rational function. Now, a rational function, you might have non-permissible values because that denominator cannot equal 0. Because if you divide by 0, yeah, that is non-defined. So x minus 2 cannot equal 0. I'm going to add for x, or sorry, solve for x. I'm going to add 2. X cannot equal positive 2. So positive 2 falls here. Now this cannot equal it, so I'm going to do an open circle. But recognize we can be any number that's smaller than this value, as well as any number bigger than this value. So this is the g of x domain. Now to figure out what the domain of f minus g is we have to find the common domain between these two things. Well, the common domain starts at positive 4 and goes on forever. So that means if we were to write the domain of f minus g, we would start at 4 and we can go to positive infinity, and I'm going to do an open bracket. So that's in set interval notation. How does this look in set builder notation? In set builder notation, we would notate it as x has to be greater than or equal to 4, and x can be any real number. And I'm going to close that off with a bracket there. Okay, so we found the common domains and then stated the domain of our difference operation. Let's do a quick other example here. Okay, and let's go to example 2 here. Now, what is the domain of f plus gx when f of x domain is negative infinity to 4, and then g of x is negative 3 to 5. Now, again, must find common domains. In this case, we don't know what these functions are. We don't know what type of function f of x is, and we don't know what type of function g of x is, but we do have their domains already. So again, let's draw a number line so we can visually see this and see what's in common. So for f of x, it's going to be in green, and its domain starts at positive, or sorry, it can start at positive 4 here. It can equal it because it's a square bracket, okay? And then it can be any number to the left of it going to negative infinity, okay? Now how about looking at g of x? G of x I'm going to represent in black, okay? So g of x, we have negative 3 and we have 5. Now 5, they both cannot equal because they are rounded brackets. So this would look something like rounded bracket, or sorry, open circle, but it can be any number in between these things. Okay, Now to find f of x, f plus g of x domain, we have to find the common domain between these things. So what do they share? Well, they don't share -3 because this does not include it, but they share any number f greater than -3 all the way up to +4. Okay, so this is what they have in common. How do we write that? Well, we have to do an open bracket, -3 to 4, and we can include that because it's included in both of these domains. So this is the domain of f plus g of x. Okay, I will also write it in set builder notation. So x has to be greater than, but it won't equal -3, and then less than or equal to +4. And when it's any number, it can be any real number. So there are the domains. We figured out the shared domains of f of x and g of x, and we were able to find the sum operations domain